Okay, the last concept that we have for 3.3 is something called extreme values. We're looking for different types of maximum and minimum values. So the first one that we're going to start with is absolute maximum or minimum. And just like absolute sounds, it is the biggest maximum or the biggest minimum. So meaning we are looking for the highest or lowest points on the graph. So when we're looking for maximum values, we're looking for the y value because the maximum or minimum is the function value. So you're looking for like the maximum area, the maximum revenue, something like that. You're looking for the y value. So what does this mean? If we're looking for the absolute maximum, we are looking for the highest point on the graph. That means there is no point that is higher than the point that you found. And if you're looking for the minimum, you're looking for the lowest point. So let's look at our example over here, this graph that I have drawn, and let's talk about the absolute max and absolute min for this graph. Okay, so absolute maximum, we're looking for the highest point on this graph. So where is the highest point? Well, it's not, this is a high point, but it's not the highest point because there are other ones above it. So not this one, but this one right here, that is the highest point on the graph. There is no part of the graph that goes above it. So at this point, we know that we have a maximum. So our maximum happens at x equals 4, and the y value is 6. So the way that we write that is we say that f of 4 is equal to 6. 6 is our actual maximum value. Okay, so it happens at 4, but our actual maximum value is 6. So that's the way that we write it. All right, so now absolute minimum. Is there a point that is the lowest point on the graph? Well, we've got a low point right here, but is it the lowest point? No, because the graph keeps going down beyond that. There are points lower, and in fact, no matter what point we picked, we could always find another point that's lower than it. So for absolute minimum, we would say none. There is no low point on the graph because it keeps going on forever downward. Okay, so that's absolute maximum or minimum. Now there's another type of maximum minimum called local maximum or minimum. Okay, so local means that if you look at a small area around that point, does it look like a maximum or minimum? So we look at a small area around that point and decide if it looks like a maximum or a minimum. So for this one, let me switch colors here. Okay, so let's start with this one at -2, 3. All right, if we look at a small area around it, meaning we're looking at a little circle, and in math, when we say small, small can be as small as you want to make it. So infinitely small. You can make this circle any size you want. So if we look at a little circle around this point and we ignore the rest of the graph and we just look at this little gray circle, does that point look like a maximum or a minimum? And the answer is yes. It's a high point, so in that little circle, it does look like a maximum. So that means that we have a local maximum at -2, and the value is 3. So at -2, and the local maximum value is 3. It's not an absolute max because there's a point higher than it, but in that little area, it is a maximum. Okay, do we have any other local maximums? You can have multiple of these because you're just looking at a little area. Well, at our point here, 4, 6, we're an absolute maximum. Is it also a local maximum? Well, sure, if we look at a little circle around it. Okay, does that look like a maximum? Of course it does because it was already an absolute maximum. So in that little circle, it also looks like a maximum. So we also have f of 4 equals 6. We have a local maximum at 6. Okay, now do we have any, we didn't have an absolute minimum, but do we have a local minimum? Are there any low points on the graph? Well, we've got a low point right here. If we look at a little circle of it, does it look like a minimum? Yes, that looks like a minimum. So we have a local minimum. Let me make this a little bit smaller so we can see the numbers. We have a local minimum at 1 with value -3. So at 1 with value -3, we have a local minimum. Do we have any other local minimums? Do we have any other low points? No, because the graph just keeps going down forever. Okay, so local maximum and local minimum, you're looking for these high points and low points on the graph. That's what you're looking for to find those. Okay, let's look at another example. It's a little bit different when you have endpoints. So let's say that we have this function. It's going to look like this. And here we have the point 0.5. Here we have the point 3.1. And here we have the point 6.8. Okay, so 0.5, 3.1, and 6.8 are our points. Okay, so let's look at our different maximum and minimum values. So absolute max, absolute min. All right. So do we have an absolute maximum? Do we have a point that's higher than all the other points? And the answer is yes. This point right here is the highest. There's nothing higher than that. So we have an absolute maximum at 6, and the function value is 8. Okay, 8 is the highest y value that we have. All right, do we have an absolute minimum? Do we have a point that's lower than anything else? Let's look at the graph. Yes, we do. This point right here is lower than anything else on the graph. So we have an absolute minimum at this point, 3.1. So at 3, we have a minimum value of 1. So our lowest y value is 1, our highest y value is 8. That makes sense. Okay, do we have a local max or a local minimum? Now remember, for this, you need to have an area around that point where it looks like a maximum or minimum. So let's look. We have kind of a high point here. Is it a local maximum though? Do we have an area around that point where it looks like a maximum? And the answer is no, because the function doesn't exist in that whole area. So this one cannot be a local maximum. And same thing up here. So endpoints cannot be local max or local min, because they don't. You have to have that whole area around it where it exists. So the answer for local maximum would be no. We do not have any. How about local minimum? Do we have any low points? Well, we have this one that we looked at before. Do a different color here. All right, we have this one that we looked at before. All right, that's a low point. Do we have an area around it where it looks like a low point? Yes. So this one is a local minimum. So we have a local minimum at 3, and the value is 1. So f of 3 equals 1 is also a local minimum.